Hello everybody and welcome back to the last part of Unit 9 of Regents Chemistry where we are talking about solutions. Today we'll be talking about the colligative properties of solutions and we'll talk about how ionic and covalent solutes can affect those properties. When we talk about the colligative properties, the idea is that when we're working with the aqueous solutions, which are the solutions of anything with water, as we add more solutes in those solutions, the freezing and boiling points change. And the term that we use, not the term, like kind of a phrase that we use to memorize this better, is hot gets hotter, cold gets colder. We'll talk more about that in just a second to help you guys understand what that means. For now, remember that when we are adding those solutes, it doesn't matter what type of solute are you adding. The only thing that matters here is that 1 mole of any particle, any type of solute that you're looking at, 1 mole of that particle is going to have the same effect on the freezing and boiling point. Let's see what that means. Now let's talk about the first part of this phrase that we looked at. Hot gets hotter. This is called the boiling point elevation, which means if we are looking at an aqueous solution and we add, let's say, a salt in it, that salt is going to raise the boiling point of that solvent. And the more and more salt we add, the concentration of salt in that solution is going to increase. And so basically the boiling point is also going to be higher and higher. So the more salt, the more the concentration of that salt and the higher the boiling point. So let's say water normally boils at 100 degrees Celsius. If we add salt to the water, it will raise the boiling point. And so now the water will boil at a higher boiling point. So another example of that is an antifreeze that we use in the cars. When that is added to the water, it creates a solution that increases the boiling point. So now the water in the car radiator takes longer to boil than it will normally do. And then the cold gets colder is basically the opposite side of that. It's called the freezing point depression, which means once again, if we have an aqueous solution and let's say we all add salt to that, that is going to lower the freezing point of that solution. So of that solvent. So water normally boils at 0 degrees Celsius. When we add salt to it, it lowers the freezing point slightly. And we see an example of that when we salt the roads in winter. By doing that, we are basically lowering the freezing point of water. So now it takes longer for water to freeze on the roads. Or it just requires like a very, very low temperature or super, super cold atmosphere for that water to freeze. So the way these properties are affected by the molecular versus ionic compounds is that in molecular compounds, we have, if let's say we add 1 mole of our solute into the solution, so here we are looking at sugar. If I add 1 mole of sugar into water, I dissolve it, it's going to make an aqueous solution. So that AQ right next to sugar on the product side, that represents that now the sugar is making an aqueous solution with water. Now, notice how we started with 1 mole of sugar and that is remaining 1 mole of sugar in the solution. So that's how it's going to raise the boiling point or decrease the freezing point just for the 1 mole. In ionic compounds, however, let's say I am dissolving sodium chloride, which is table salt, in anything. When the sodium chloride goes into water, it breaks down into ions. It is now breaking down into the sodium ion, which is dissolving into water, making that aqueous solution. And then I get the chloride ion, which is once again dissolving into water, just interacting with the water molecules. That's why both of them have that AQ sign next to them. Now here's what's happening is that we are starting with 1 mole of salt that we dissolved in water. However, it produced 2 moles in the solution when it broke down into sodium and chlorine ions. So now compare these two things. for the sugar, we only had 1 mole in the solution. In the ionic, in the salt, we had 2 moles in the solution. So the idea to remember here is that the more moles we have, the more properties are going to change. We are going to have more freezing point depression and more boiling point elevation. Here's another example of another ionic compound, calcium chloride. When this goes in the solution, it breaks down into calcium ion and then 2 chlorine ions. So overall, we have calcium, chlorine, chlorine. We've got 3 moles there, 3 moles in the solution. So that is going to increase the boiling point and decrease the freezing point even more than sugar and then table salt. So that's how it works. It's only affected by the number of moles that are being dissolved and not the nature or the type of compound that we are dissolving. Alrighty, so that was it for this unit, people. Take care. I'll hopefully see you in the next one.